Hello, today our topic is velocity and acceleration in different coordinate system. Before going to topic, let's start a quick review. What are the coordinate systems? You all know what are the coordinate system. There are different type of coordinate system like Cartesian coordinate system, plane polar coordinate system, spherical polar coordinate system, cylindrical coordinate system. And what are the unit vectors in different coordinate system? The unit vectors in different coordinate systems are in general I can say these are u cap, v cap and double cap. In Cartesian coordinate system, the unit vectors are x cap, y cap and z cap. And in plane polar coordinate system, the unit vectors are r cap and theta cap. And in spherical polar coordinate system, the unit vector are r cap, theta cap and phi cap. And in cylindrical coordinate system, the unit vectors are r cap, phi cap, z cap. You all know about it. Our main aim today is to discuss about velocity and acceleration, not on coordinate system. So it's just a quick review. And what are the metric coefficients in different coordinate system? The metric coefficients are general h1, h2 and h3 in curvilinear coordinate. In Cartesian coordinate, what are the value of h1 and h2 and h3? These are 1, 1, 1. And in plane polar coordinate, what are these value? These are 1 and r. In spherical polar coordinate, what are these value? 1 r, r sin theta. And in cylindrical coordinate, what are these value? 1 r 1. Okay, you all know about it. Now let's start our topic. What is velocity? You all know velocity is defined by relation the rate of change of length element. Okay, but I am asking a conceptual question. Is the direction of velocity same as direction of displacement vector? What are the answer? I think you all say it's yes. The direction of velocity are same, but no, always the direction of velocity and direction of displacement is not same. How? Let's see how. Let A be any initial point. Let A be any initial point and B be any final point. And a particle move from A to B. Then what is the displacement? The displacement direction is this, that is dl vector. But what about the direction of velocity at point A? This is the tangent. And what about the direction of velocity at point B? This is the direction. Is the direction of a velocity at point A and dl are parallel? No. Is the direction of a velocity at point B and dl are parallel? No. So we can say that always the direction of velocity and direction of displacement is not equal. Yeah, the direction of velocity and displacement are equal when we say about motion in straight line. But when the motion is not in straight line, we can say that the direction of velocity and direction of displacement are not same. I hope you understand this. So before proceeding velocity in different coordinate system, I am going to say about what is length element in different coordinate system. First of all, in Cartesian coordinate system. In Cartesian coordinate system, what is the length element? The length element will be dl vector, that is dxi cap, dxi cap or dxx cap plus dyy cap plus dz z cap. Okay. But what about length element in spherical polar coordinate system? In spherical polar coordinate system, the length element will be dr r cap plus r d theta cap plus r sin theta d phi cap. You all know about it in mathematical physics. Just multiplication of a metric coefficient. Now, what is the length element in cylindrical coordinate system? In cylindrical coordinate system, the length element is dr r cap plus r d phi cap plus d z z cap. Okay. Now come to the point. What is the velocity will be? The velocity will be in Cartesian coordinate system. What will be it? Dx by dt x cap, because we know v is equal to dl by dt. So we can put the value of dl from the above equation. What is velocity b? V is equal to dx by dt x cap plus dy by dt y cap plus dz by dt z cap, or we can say dx by dt as vx x cap, that is velocity in the direction of x, similarly velocity in the direction of y, similarly velocity in the direction of z. Now what is vx? Vx is equal to dx by dt. What is vy? Velocity in the direction of y, that is dy by dt. And what is vz? That is dz by dt. Now what is the square of velocity? That is v square. We know v square is equal to v dot b. If we dot product v dot b, what we will get? Vx square plus vy square plus vz square, isn't? Because x dot x is equal to 1 and y dot y is equal to 1 and z dot z is equal to 1 and the inter dot product is 0. That's why this term. You all know about it. And what is the kinetic energy T? T is equal to half mv square. Just put the value of v square. Yeah. What will be? Vx square, vy square, vz square. Why I write the kinetic energy term? It will require to know the acceleration easily in different coordinate system. Now, what is velocity in spherical polar coordinate system? You know velocity is equal to dl by dt. Then what will be it? It will be dr by dt r cap plus r d theta by dt theta cap plus r sin theta d phi by dt phi cap, or we can say it r dot r cap plus r theta dot theta cap plus r sin theta phi dot phi cap. I just wrote the dou by dt term as a dot in classical mechanics. Now what is Vr? Vr is the velocity in the direction of r cap. What will be it? That is r dot. And what is v theta? That is r theta dot. See, and what is v phi? That is r sin theta phi. R sin theta phi. I hope you understand. In Cartesian coordinate system, what is the velocity Vx? Is equal to dx by dt. What is vy? Dy by dt. And what is vz? dz by dt. But in spherical polar coordinate, what is vr? Vr is equal to r dot. What is v theta? Not simply theta dot. It is r multiply theta dot. That is the multiplication of scalar element or metric coefficient with theta dot. And what is v phi? R sin theta phi cap. And what is v square? The v square will be r dot square plus r square theta dot square plus r square sin square theta phi dot square. No, it's just a dot product of this. Okay, then what is the kinetic energy? The kinetic energy will be half m r dot square plus r square theta dot square plus r square sin square theta pi dot square. And this is necessary to calculate acceleration. Now what is velocity in cylindrical coordinate system? The velocity in cylindrical coordinate system is v is equal to dou L by dou t. We know dou L, that is dr r cap, r d phi phi cap, and dz z cap. Then what is velocity? By just putting dl dr by dt r cap plus r d phi by dt phi cap plus dz by dt z cap. And I can write it as r dot r cap plus r phi dot phi cap plus z dot z cap. And what is vr? That is velocity in the direction of r, that is r dot. And what is v phi? R phi dot. And what is z vz? That is z dot. And what is square of velocity? That is r dot square plus r square phi dot square plus z dot square. And what is kinetic energy? Kinetic energy will be half m r dot square plus r square phi dot square plus z dot square. The general acceleration formula in any coordinate system can be written as AI. AI means ith component acceleration is equal to 1 by mhi dou by dou t, dou capital T by dou qi dot minus dou t by dou qi, where m is equal to mass, hi is the corresponding metric coefficient, t is the kinetic energy, qi generalized velocity, and qi generalized coordinate. Now, how we are going to use this formula to get any acceleration component? Let's find out. In Cartesian coordinate, system, what are I? I can be x, y, or z. What is t in Cartesian coordinate system? We saw what is t? Half m x dot square plus y dot square plus z dot square. And what is h1, h2, h3? In Cartesian coordinate, h1, h2, and h3 is value 1, 1, 1. Then find x. What is x component of acceleration? The x component of acceleration be 1 by m, because h1 is equal to 1. 1 by m dou by dou t by dou x dot minus dou t by dou x. We have capital T. By differentiating, what we will get? We will get 1 by m into dou by dou t to mx dot minus 0, that is 1 by m into 2m into x double dot. Sorry, some mistake here. Now what will be x? X is equal to x double dot. Similarly, you can find what is ay? Ay is equal to y double dot. And what is az is equal to z double dot. In Cartesian coordinate system, this formula is so simple. You can directly say that the acceleration component is h double dot, y double dot, z double dot. But what about in other coordinate system? In other coordinate system, this formula will play a very easy role to find the component. Let's see how. In spherical polar coordinate system, what is I? I can be r theta phi. And what is t? You remember, I write what is t? Half m r dot square plus r square theta dot square plus r square sin square theta phi dot square. And what is h1, h2, and h3? The h1, h2, and h3 are 1 r sin theta. Now let's find what is the radial component of acceleration in spherical polar coordinate system. In spherical polar coordinate system, we know what is kinetic energy T, that much, and what is air according to formula 1 into m into 1 dou by dou t, dou capital T by dou r dot minus dou t by dou r. And how much is this? This is 1 by m. This is m r double dot minus r theta dot square minus r sin square theta phi dot square. Just put the value of t and differentiate with respect to r dot, and you will get this. And this is the radial component of acceleration, that is ar is equal to r double dot minus r theta dot square minus r sin square theta phi dot square. Now we can see what is the theta component of acceleration. The theta component of acceleration be 1 by m into r dou by dou t by dou theta dot minus dou t by dou theta. Now what we will read by putting just t, the value will be 1 by r. M will be, I take m common and just cancel it out. So the answer will be 2r r double dot theta dot plus r square theta double dot minus r square sin theta cos theta phi dot square. And this is a theta is equal to 2 r dot theta dot plus r theta double dot minus r sin theta cos theta phi dot square. And this is theta component of acceleration. Similarly, you can find out the phi component of acceleration, that is 1 by m r sin theta dou by dou t by dou phi dot minus dou t by dou phi. By just differentiating, you can calculate a phi. I just wrote this example to show you how easy to find the radial component and the theta component and phi component of acceleration by the formula I show before. In cylindrical coordinate system, we know kinetic energy T is equal to that much, and h1 and h2 and h3 is 1 r1. And what is the radial component? The radial component AR is equal to 1 by m into h1. h1 is 1 into dou by dou t by dou r dot minus dou t by dou r dot. Differentiating with respect to r dot and r, what I will get? I will get AR is equal to r double dot minus r theta dot square. You just differentiate and see how is this. And a phi, what is the phi component of acceleration? For phi component of acceleration, I can write 1 by m into h2. And what is h2? h2 is r. And the formula dou by dou t by dou phi dot minus dou t by dou phi. Just differentiate with respect to phi dot and phi. And the t contain phi dot but does not contain phi. So the formula will be 1 by r dou by dou t r square phi dot. And just again differentiate with respect to time, we will get a phi is equal to 1 by r dou r dot phi dot plus r square phi double dot, which is equal to r square phi dot square a phi double dot plus 2 r dot phi dot. And this is the phi component of acceleration. And what is the z component of acceleration? For z component of acceleration, 1 by m into h3. What is h3? h3 is 1 into dou by dou t by dou z dot minus dou t by dou z. And what will be it? By just differentiating t with respect to z dot and z, we will get a z is equal to z double dot. Now I start with a basic question. If a component of velocity is equal to 0 is equal to constant, then is it true the component of acceleration is equal to 0? We know vi, we know ai is equal to dou vi by dou t. But is it always true if vi is equal to constant and ai is equal to 0? The answer will be, you think yes, but it actually no. Why it's no? Let's discuss why it's no. We know in Cartesian coordinate system, vx is equal to x dot and ax is equal to x double dot. We just calculate it before. Now see, if vx is equal to x dot is equal to constant, then what is the x? X is equal to x double dot, just the double derivative, and the double derivative of this constant term is equal to 0. So this is true. Now see, in cylindrical coordinate system. In cylindrical coordinate system, we know vr, the r component of velocity is r dot, and the the radius component of acceleration is r double dot and r phi dot square. If vr is equal to constant, that is r dot is equal to constant, is ar is equal to 0 or not? Let's see. ar is equal to r double dot minus r phi square. If r dot is equal to constant, I can say r double dot is equal to 0. If r double dot is equal to 0, then what is ar? Ar is equal to minus r phi square, phi dot square, which is not equal to 0. So in general, if vi is equal to constant, this is not always true that ai is equal to 0, because ai is not simply the time derivative of vi. It can contain extra term, as we see in the cylindrical coordinate system. In cylindrical coordinate system, vr is equal to r dot, and ar is not simply r double dot. It's not just the second derivative of r, but it also contains some extra term. The same extra term does not allow it to become 0. I think you understand it well.